Young Albert Einstein was not what you might call a model pupil. In his early years, many people did not see the spark of genius. He was a quiet child and he started speaking quite late. This made some of his family worry about his development. His headmaster once told his father, Hermann Einstein, that it did not much matter what career Albert chose. The headmaster believed he will never make a success of anything. This harsh judgment followed Albert through his early school days. School life in Germany in the late 19th century was very strict. It was all about discipline and learning facts by heart. Albert did not like this way of learning at all. He preferred to think deeply about things and ask questions. This often got him into trouble with his teachers. They saw him as rebellious and not very interested in his lessons. One teacher even told him he would be better off leaving the school. Albert felt like an outsider, struggling against a system that did not understand his unique way of thinking. His mind was already wandering to bigger ideas. When Albert was a teenager, his family moved from Germany to Italy. Albert was left behind to finish his schooling in Munich. He disliked his school so much that he eventually found a way to leave. One of the most important moments in Albert Einstein's childhood happened when he was about 5 years old. He was ill in bed, and his father gave him a magnetic compass to play with. Young Albert was absolutely fascinated by it. He marveled at the way the needle always pointed north, no matter which way he turned the compass. He realized there must be some invisible force acting upon it. This simple toy sparked a lifelong curiosity about the unseen forces that govern the universe. This early sense of wonder was nurtured by books. As a teenager, Albert read many popular science books. He devoured texts that explained the great discoveries of the time. He also became interested in philosophy, particularly the works of Immanuel Kant. These readings encouraged him to think for himself and to question everything. He wasn't content to just accept what he was told. He wanted to understand the fundamental principles behind the world. After graduating from the Zurich Polytechnic in 1900, Einstein faced a difficult period. He had hoped to get a job as an assistant at a university. However, his independent nature and sometimes disrespectful attitude towards his professors had not won him many allies. He applied for many academic positions, but he was rejected time and time again. For 2 years, he struggled to find regular work, sometimes tutoring to make ends meet. It was a frustrating and disheartening time for the young physicist. Just when things seemed bleak, a lifeline appeared. The father of his good friend Marcel Grossmann helped him get a job. In 1902, Einstein started working as a patent clerk, an expert third class, at the Swiss Patent Office in Bern. This job might have seemed like a step away from his academic ambitions. However, it turned out to be a blessing in disguise. The work was not too demanding. It required careful, logical thinking, which suited him. Crucially, it provided him with a steady income and, most importantly, free time. He often called his desk at the patent office his worldly monastery, a place where he could hatch his most beautiful ideas. The quiet routine of the patent office allowed his powerful imagination to roam free, undisturbed by the pressures of academic life. The year 1905 was truly extraordinary for Albert Einstein. It is often called his Annus Mirabilis, which means miracle year in Latin. While still working his modest job at the patent office in Bern, this seemingly ordinary 26-year-old clerk produced a series of scientific papers. These papers would completely transform our understanding of the universe. One of his groundbreaking papers, published in 1905, dealt with the photoelectric effect. Einstein proposed a revolutionary idea that light itself could behave not just as a wave, but also as a stream of tiny packets of energy, or particles, which he called light quanta. This concept was a crucial step in the development of quantum theory. It was for this work, not relativity, that Einstein would eventually receive the Nobel Prize in Physics in 1921. Another paper from that miracle year provided strong evidence for the existence of atoms and molecules. Einstein's paper explained Brownian motion. This paper helped to finally settle the debate and firmly establish the atomic theory, but the most famous papers of 1905 were those that introduced the theory of special relativity. Section 5. Special Relativity, a New Understanding of Time and Space. The theory of special relativity, unveiled by Einstein in 1905, was a profound departure from centuries of scientific thought. Its two main postulates were deceptively simple. The first stated that the laws of physics are identical for all observers in uniform motion. The second postulate was more radical. The speed of light in a vacuum is constant for everyone. These ideas had mind-bending consequences. They directly challenged the absolute concepts of space and time established by Sir Isaac Newton. For Newton, time flowed at the same rate for everyone, everywhere. Space was a fixed, unchanging stage. Einstein showed this was not true. According to special relativity, time can dilate or stretch. A clock moving very fast relative to an observer will appear to tick slower than a stationary clock. Similarly, lengths can contract in the direction of motion. An object moving at high speed will appear shorter to a stationary observer. Space and time were no longer separate and absolute, but interwoven into a single continuum, space-time. From the principles of special relativity, Einstein derived the most famous equation in all of science, E equals mc squared. Section 6. Resistance and ridicule, the fight for his theories. Despite the brilliance of his 1905 papers, Einstein's ideas weren't immediately embraced. Many physicists were attached to Newton's classical physics. Newton's laws had explained the world for over 200 years. Einstein's theories, especially special relativity, seemed to defy common sense. The idea that time wasn't absolute felt bizarre to many. Some dismissed his work as mere mathematical speculation. There was a lack of direct experimental proof for special relativity. Effects like time dilation only become significant at near-light speeds. Such speeds were hard to achieve in early 20th century labs. This made it hard to convince skeptics demanding concrete evidence. Einstein had to wait for technology to catch up with his insights. He possessed a quiet but firm confidence in his work. Section 7. Proof from the heavens. The eclipse that changed everything. While special relativity dealt with uniform motion, Einstein knew it was incomplete because it did not include gravity. For 10 years, from 1905 to 1915, he wrestled with this problem. His goal was to create a theory of gravitation that was consistent with the principles of relativity. The result was the General Theory of Relativity, published in 1915. This was an even more revolutionary achievement. It described gravity not as a force pulling objects together, as Newton had proposed, but as a curvature or warping of space-time caused by mass and energy. General relativity made several testable predictions that differed from Newton's theory. One of the most dramatic was that gravity should bend light. According to Einstein, the immense gravity of a massive object like the Sun should warp the space-time around it. Starlight passing close to the Sun should follow this curvature, appearing to be slightly deflected from its original path. The perfect opportunity to test this prediction came during a total solar eclipse. When the moon completely blocks the Sun's disk, the sky darkens enough for stars near the Sun to become visible. British astronomer Sir Arthur Eddington realized that the solar eclipse of 29 May 1919 would be ideal for this experiment. Section 8. A New Cosmos, How Einstein Reshaped Physics Forever. The confirmation of general relativity in 1919 made Albert Einstein famous. It changed our understanding of gravity and the cosmos. Newton's gravity was replaced by Einstein's space-time geometry. Massive objects curve space-time, guiding other objects' movements. This new perspective explained gravity in strong fields and cosmological scales. Einstein's theories opened new fields in physics and cosmology. General relativity predicted phenomena like gravitational waves. It suggested the universe might be expanding, confirmed by Hubble. It also predicted black holes, and foresaw gravitational waves from cosmic events. These waves were detected in 2015, confirming Einstein's genius. Einstein's theories have practical applications on Earth. For example, GPS relies on accurate timekeeping. Section 9. The Enduring Light. Lessons from a Reluctant Genius. Albert Einstein's journey is a remarkable story of transformation. He went from being a boy whose headmaster thought he would never make a success of anything, to a young man struggling to find his place, and finally to a global icon whose name became synonymous with genius. His early difficulties, the rejections from academia, and the initial skepticism towards his ideas highlight the importance of perseverance. He did not give up on his vision, even when faced with significant obstacles. His story teaches us that setbacks can be overcome with persistence and a strong belief in one's own path. Central to Einstein's success was his willingness to think differently. He dared to question the most fundamental assumptions of physics. ideas that had been accepted for centuries. His famous quote, "Imagination is more important than knowledge. For knowledge is limited, whereas imagination embraces the entire world," captures his approach. He used thought experiments and his powerful intuition to explore new possibilities. He was not afraid to be unconventional or to challenge the established order. This out-of-the-box thinking was crucial for his revolutionary breakthroughs. He showed that true innovation often comes from looking at old problems in entirely new ways.